dynamic analysis is analyzing software while it's running. And so often there's many types of dynamic analysis, just like there's many types of static analysis, but often it's trying to find inputs to software while it's running to break the software. And sometimes the breakage of the software is security related, sometimes it's not, but often if you find something that, some behavior of the software that is unexpected, then you might be able to adjust that to get to a security issue. And so that's a whole different area of research, as you were mentioning. The benefit of dynamic analysis is that you have basically every incident is a true positive, right? That something really breaks, yeah. Right? We know it broke, so there must be something wrong with the software that allowed it to break. Whereas with static analysis, as we mentioned, a significant concern or challenge is the amount of false positives, right? We get lots of alerts that maybe something in the code isn't right, but it might actually be mitigated somewhere else in the code, so you can't actually attack and there's no real vulnerability. So basically every security incident or security finding that you have in dynamic analysis is a vulnerability of some type. And from the,
or at least an error.
Well,
that could become a vulnerability. Yeah.
What I was going to say from the information assurance model of confidentiality, integrity, and availability, often it might just be availability. Right. We crashed it, and you don't want it to crash. And maybe that's all it is, but it crashed. And so they're coming from two different angles. But as research has kind of continued, they're starting to merge to try and get the benefits of both worlds. And so we have different types of analysis that are merging different types of things like call execution or other methodologies that are trying to use, again, depending on the direction you're coming from, either first use binary or dynamic analysis to find the vulnerability, and then go back and look at source or static analysis to try and find where it is.
Right. And that's the happy scenario where you've got the binary and the source code.
Exactly.
And at least some mapping between the two.
That's right. Because what I didn't mention was the challenge with dynamic analysis. The challenge is fixing it. So now we know that there's something in the code that breaks, and this input that causes the unexpected behavior, but we don't necessarily know where in the code, from the source path, that the execution path, where it failed. And so trying to find what the fix should be is a problem. Now, some researchers are, as I mentioned, just trying to fix the binary, and they don't care about the source code because it might be hard to find or because they don't have access to the source code. But that then hurts the ability for maintainability and making sure that you don't have a regression error the next time you update that code or your contractor updates the code. So the happy medium is then using static analysis and source code analysis to try to find where a lineup of weakness in the code to the vulnerability. And similarly, if you're starting with static analysis, people are using dynamic analysis methods to try to identify whether or not that particular weakness will lead to a vulnerability.
Is a true positive.
Yeah.